Okay, good morning everybody. I'll get started because I think we're quite pushed for time really today. There's quite a lot to go through in the 20 or so minutes. My name's Jason Reed. I'm one of the account managers at Pilz Automation. If you have any questions during the presentation, I've been asked if you can come and see us at stand 41 after the presentation and we'll run through any questions that you have. So the agenda for this morning, really, we're going to talk about cybersecurity and keeping machinery safe. So we'll run through safety and security, how that kind of fits hand in hand. We'll look at cybersecurity legislation, standards. We'll look at the IT versus the OT. We'll look at possible side effects of the safety-related parts of the control system. We'll then go through risk assessments via zones and conduits, and then we'll end with some countermeasures. So safety and security go in hand. So security vulnerabilities enable machinery safety to be manipulated. And so we're all familiar with machinery safety and how we protect our employees from hazards from the machine themselves. And then we have security, which protects the machine and data from manipulation from unauthorized access. So that's really protection against corruption. So if we look at security aspects, we have physical security, and that is protecting the machine from personnel. So it's stopping you from getting access to flaps, doors, guards when you shouldn't. And then we have protection against information security, which is the data from attacks. So cybersecurity legislation. So as it stands, we have for machinery safety, we have the Machinery Directive or the Supply Machinery Safety Regulations. And then we used what are called harmonized or designated standards to ensure that our machine is compliant with that directive or regulation. With security and with safety now, we have the Machinery Directive becoming a regulation. And that means that there's going to be some 600 to 800 standards that will need to be reharmonized to the machinery regulation. And there's now an emphasis with that regulation for cybersecurity. So the machinery regulation will now have protection against corruption, and there's a security focus on functional safety functions. For standards, we have a recent update to 13849, and there's a requirement there for access to functional safe controllers. And so we need to look at the new employees and their skills, and that's explicitly mentioned within the standard. And that there should only be access for qualified personnel only. And then for security, we have the Network and Information Security, NIS2, which is being released in Europe, which addresses both what's called essential and important entities, so like water utilities, energy, etc. And then we have the Cyber Resilience Act, which places an obligation on manufacturer of products with a digital element. How will this affect the UK, not being part of the EU and therefore the directives? Well, the UK government, the previous UK government, has already said that it won't accept the NIS2. But they are working on a UK cyber security and resilience bill, and there are some commonalities between the two. But if you are a manufacturer of equipment in the UK and you're supplying it into Europe, then you will need to fulfill these obligations. Likewise, if you're an OEM and you've got facilities or you're part of a multinational, again, you're most likely going to have to follow these directives. So an overview of the machinery regulation and the changes. There's now the inclusion of so-called emerging digital technologies. So AI is not mentioned specifically, but we can tell it's AI by the way it uses self-evolving behavior. We have the inclusion of cybersecurity and associated safety requirements. There's the requirement for human-machine interaction. And then there's the requirement for authorization and access rights in relation to the safety and reliability of control systems. So connection of additional equipment must not lead to the loss of a safety function. Remote access devices must not be affected. must not affect safety, sorry. Hardware components that are important for connecting and assessing safety-related software must be adequately protected against unintentional and deliberate corruption. The machine must collect evidence of lawful or unlawful tampering with the hardware. Software and data relevant to safety shall be identified as such and should adequately be protected again against unintentional and intentional corruption. And the machine must collect evidence of tampering with any safety-related software, and the machine must identify the safety-related software installed. And so what we're talking about here is not necessarily a teenager or a state-sponsored attack of your machine. It could quite easily be an employee that unintentionally makes a mistake on a HMI and causes some corruption to the safety parts of the control system. You need to be able to protect yourself against that. So we interpret this at Pilz that the regulation really is about protecting safety via security measures. And the machinery regulation comes into effect on the 20th of January 2027. So machinery safety is in a state of transformation. So if we look at, we have manufacturers of electrical equipment, we have machine builders, and we have critical infrastructure. And then we have it could be our production manager, it could be our blogger, YouTuber. They're connected remotely via, it could be a handheld device, for instance. And then we have our attacker. And so NIS2 will be important for manufacturers of electrical equipment, but the Cyber Resilience Act is covered by them. So companies like Pilz that make products with electronic elements will have to comply with the Cyber Resilience Act. Machine tool builders will be covered by NIS2, but also the new machinery regulation. And then if we look at critical infrastructure, NIS2 will become an essential entity for them. So cybersecurity standards, really there's two we're going to look at today. We have ISO 27000, and this really is about information security management. So it's all about processes and procedures that you have within your organization, what kind of patch management should you be looking at, etc. Information security controls, training of your employees, etc., etc. And then we have IEC 62443, which is for security for industrial automation and control systems. And this is for application and for products. So you can see that it covers both the factory systems and components. To give you an idea of the changes between machinery safety and security, this is a typical process that we would see in machinery safety. So we would start with a risk assessment, safety concepts. We would go through to safety design, system implementation. We would then do our safety validation, and then we would apply relevant CE mark, etc. to it. With security, it's quite a different approach. So we'd still do our security risk assessment. We would have our security concepts, and we would then have a target security level that we'd want to potentially achieve. We would use 62443 to be able to assist us with this. We would then do our security design. We would then do security verification. We wouldn't really do any validation as such because we don't want to start to stick viruses on your system to prove that it works. So you just do your verification. But it wouldn't stop there like it would for a machine. It would be a continual process because we're all familiar with getting updates for our phones, for our laptops, and that again will be part of your machine, is that you'll get, a new patch come through, and you'll have to look at then, what are the security assessments by doing a risk assessment associated to that. So information technology versus operational technology. I'm not going to go too much into this because of time, but we're all familiar with IT and the infrastructure that's behind that. With our OT network, it's pretty much been around for many, many years, the equipment has, but the need to connect the two together is more of a recent transition with the Internet of Things, Industry 4.0. And what you generally find is that because the equipment is older, then the IT behind it, again, is obsolete, is out of date, and is no longer kept up to date, like Windows 98, for example. And so we need to look at different security objectives and determine what is kind of like our priorities. And we use what we call the CIA method. So we look at confidentiality. This is data may only be read or modified by authorized users. We have the integrity, so data may not be unknowingly modified. And then we have the availability, which is prevention of system failures. And depending on kind of, if you're an IT network, you'd probably find that confidentiality would be your number one, then integrity, followed by availability, because if a laptop was to fail or a printer fails, generally there's a spare one that you can use. In the OT, you generally find that availability would be the number one priority, maybe then followed by integrity and confidentiality, because if your machine was to go down, you can't just go to the stores and get another machine out from the stores and start to manufacture. So what are the possible side effects on the safety-related parts of the control system? So here is our system here. We have our safety and our security. So if there's a threat to our security, if that's succeeded, that can exploit a vulnerability. And again, that vulnerability can have a consequence on an asset. And that could be a component, a human, for instance. There are other consequences, like environmental, etc. But it could also lead to a security risk to the safety control system. And if that happens, then you could have failure of a manipulation of the safety-related control system. That could then lead to a potential fault with a degradation. So it might be that somebody delays the stopping time of a light curtain for the performance, and then that obviously could lead to harm. So we need to protect ourselves against that. How do we do this? So if we look at organizational security measures, if we use the analogy of an airport, we have security check-in rules. So this would be our 27000. So information is posted on security posters and procedures. They're generally found at any airport and checkpoints. You have public announcements, don't leave your luggage unattended, for instance. These are all really operational measures, organizational measures. And then we have our physical measures to 62443, for example. This would be video surveillance. We may have regular police controls. And then we'd have identification and authentication. So at the ticket counter, am I the correct person to get the flight, for instance? At the border control, who am I? Am I allowed to enter, leave the country? At the boarding gate, am I allowed to board the plane? And then finally, for airport staff with their cards, are they allowed into restricted areas? So if we look at this principle for zones and conduits, any airport really is segregated into different zones. So our green zone is our public zone. It's not ticketed. Anybody can be there. Our red zone is our ticketed area. And if I want to, and then also each gate would have in this instance, it's got a blue circle to denote where you would go for the plane. And so in order to move between these zones, we need to have a conduit, and they would have specific rules that are defined. And so to move between the red zone, the ticketed zone, the green zone to the red zone, I need to have a valid ticket. I might need my passport, etc. I need to identify and authenticate who I am before I can move through. And then to move from a ticketed passenger zone to the airplane, again, I must present my boarding card. And if I don't have that, I can't get through. So these checkpoints between the zones with their different rule sets are very much like a firewall in the IT and the OT environment. And so if we now use 62443 and we look at our industrial automation and control system, which is in the red box, then our IT is everything outside of that. We now need to group all of our hardware together. So we'll group all our safety systems together. We might have some Wi-Fi ports that we'll group together. All our OPC servers, our industrial PCs, we'll group those together. And then what we'll do is we'll then have to look at how is data communicated between each one, and that would be our zones. And so how are maintenance communicating to the automation? Are they going through safety? Are they going through the automation directly? And then what we need to do then is set up our rules, like what you saw in the airport analogy, really, of as to who can connect via which kind of zone and conduit. Once you've done that, you then have to look at countermeasures. And in my mind, it's pretty much like if you're doing a risk assessments 12100, you have your inherently safe design, then you have your safeguards like a light curtain, an interlock, etc. These are really ways of being able to then protect yourself in the security environment. And so we have things like identification and access, there'll be VPNs, we'll have to look at firewalls, log servers and backups, for instance. And so countermeasures really cover the hardware that can be used to support our foundational requirements. So one of the things that's starting to happen now are what are called safeguarding support systems. And what a safeguarding support system will do really is that will allow you to have identification of authorized personnel. You can have verification that authorization for the selected task matches the identified person. We can inform the user of unauthorized tasks. We can enable the mode of what's called safe operating, corresponding to selected tasks. And we can specify the zones to which authorized personnel have access to. And this effectively means that going forward in the future, mechanical, non-individualized keys, which are generally left in a panel that you can have in a run mode, an inch mode, etc., will be phased out because you won't be able to identify and authenticate who is doing what to that machine. So again, with safeguarding support systems, we have our identifications. That's like a passport or your driving license. And then we have access management. And we look at access not just from security, but also from safety as well. And so what can we protect? So we can protect access management. So we can do away with passwords, for instance, because the key would allow you to gain access to data, HMIs. Because from a security point of view, a HMI is seen as a security potential breach. And I may see a colleague clear a blockage on a HMI 1 week. They're trained to do so. The following week, I turn up on site. The same thing happens. Oh, I know what to do. I saw what John did. And then I make a mistake and my machine's down. That's unintentional, and I need to protect myself against it going forward. The ability to operate safe operating modes, machine maintenance, safeguarding, and then we can also do machinery security as well. And if you want to see some products, we can obviously show you those. So this is a before and after picture, really. So here's our before picture. We've got our HMI, we've got an Ethernet USB port, we've got our mechanical key where we can change the status mode of the machine. So there's no identification, key's always inserted, there's always a direct USB and an Ethernet connection. And so what we can do afterwards, and these are really from our risk assessment, our security risk assessment, and then from the foundational requirements, we're now identifying and authenticating who can do what. So with the correct key, I can have access to the HMI. Otherwise, if there's no key, I have no access. And then also, I can't randomly just connect my phone to charge it or connect a laptop, because again, these ports will be disabled unless I put a key in that's got all the correct permissions that says I'm trained, competent, and I'm authorized. And then I'd be able to enable these ports and then be able to establish communication. So you can see here, and then if you wanted to do remote diagnostics, so you may have a company in Spain, for instance, that wants to gain access to my factory in the UK, and they want to have a look at what's going on with the system. They might want to do updates, for instance. I've got my firewall and my VPN, so even though they've got all the correct credentials to be able to get through, they can't actually gain access unless somebody on site by the machine. So it's kind of like a two-factor authentication. I'd have to come along with my key, I'd have to identify and authenticate who wants to gain access. And if they had that, and if the machine was safe and I wanted to allow them access, I insert my key, and then it allows that final connection to happen, and they can now gain access to the machine control system. That was a lot to go through. It was quite quick. I hope you found it informative. If there's any questions, please come and ask myself or my colleagues. We're just at stand 41, and enjoy the rest of the day. Thank you.